Today's class is going to be common for each one of you. So irrespective of you have opted for AWS or Azure based AI machine learning, this session is going to be equally helpful for each one of you. The agenda of today's session, day one, is right here. We are going to cover up what is AI, what is machine learning, what is deep learning, what is generative AI on a very high level overview. We are at the end of the course. Okay. So this is about Azure, I hope, because AWS is what we are going to start. Then we will see a comparison of various technologies which we discussed. Then we will also see what is machine learning and how is it actually different from traditional programming. We will also see what are various types of machine learning. Those who are near the end of this course, probably you already know about what is supervised learning, unsupervised learning. Maybe most of this information is kind of a repetition or a recap for you to remember all the concepts at a conceptual stage. I also want to highlight that today, day one, we will only and only focus on conceptual understanding. I have taken a bunch of webinars in the recent past, around in the last 10 days, and I have realized that there are people from various backgrounds. They have different backgrounds. There are people who are very new to AI ML, and there are people who have good amount of experience with AI ML. Sorry. So depending on what's your understanding, the conceptual topics that we are going to cover up today will bring everybody to the same page. So from tomorrow, we will go with a mix of theory and concepts and the hands-on lab, of course. Right. So we will also talk about what is the process overview for machine learning. We will see some of the AWS services for AI, ML, and generative AI. As I said, that today's topic will be more conceptual in nature. So we will not lean very much towards towards AWS. It will be very neutral for AWS and Azure people. But going forward, we will lean towards AWS. That's going to be my session. And we'll end it up with question answers and what are the next steps to talk about. Apart from this, I also want to highlight before I proceed further that I hope you are aware, we are going to have the session at the same time, depending on what time zone you are in. It'll start at this time and it will go for 3 hours. Okay, there is an announcement for everybody. I want to highlight that. It is by Vishal. Please check the chat message. Those who are here for Swami Sir session, please join the other link. Okay, please follow this as an instruction, as an immediate instruction. If you are in the wrong class for some or the other reason, please drop off. There is another class for you, which you should join in. Okay, so the sessions will go for 3 hours every day on Saturday, Sunday only. Right now in India, I am sitting at 7:30 approx PM of Saturday. I'll do the same thing tomorrow as well. And we will repeat it on every weekend. Now, this is going to span across for 10 onwards classes. There can be 10 plus classes of this. Because we are engaging for 5 weeks, more than a month, there can be a chance of any human involvement or for some or the other reason we have to postpone the class or we have to reduce the size of duration of class from 3 hours to 2 hours, or maybe sometimes you have to increase the duration. Whatever it will be informed to you prior. The default is every Saturday and Sunday we will join at the same time as you did today. Great to see all of you joined on the mentioned time without any delay, and we will be connected for 3 hours. Let us talk about me. So I am Harsh Sharma. You can see a decently nice picture of me on the right hand side. I am a technical trainer from India. And why I am allowed to teach this session, what makes me credible to teach this session. I am authorized instructor for AWS, and I'm also authorized instructor for Microsoft, and I'm also authorized instructor for CompTIA. Here in this session, I will use all of my knowledge of Amazon AWS, all of my knowledge of Microsoft Azure, and CompTIA is not much on the AI side, to be honest. But whatever I know about AWS AI, whatever I know about Microsoft AI, whatever my prior experience is, I have been working as a consultant and have executed a bunch of my startups, which are product driven. And there are different types of products we worked with. All of that experience of 6.5 years of AI and machine learning, I will be bringing in this session. I am practicing generative AI since its initial days. It's not a very old technology. It's hardly 3.5 years old. So from the time it was launched as a person who was an AI enthusiastic in that domain, I have learned that along with many other people. I have implemented projects on that. And in the later on days of this session, I will also bring in a lot of different topics from generative AI, which is the buzz in the market right now. I hold a bachelor's and master's degree in AI. If it helps you, from any academic standpoint, and I have decent amount of training experience. I have been training corporates completely from last 4 years with no other distraction. But before that, I have been teaching universities and colleges and different workshops at an initial stage of my training career. But from last 4 years, I have been completely involved in corporate trainings, and wherein the audience is all the way from 25 years of age to 50, 60 years of age with varying working experience from different domains, from banking to finance to insurance to technology and whatnot. Worked with some of the leading global organizations, which are across the globe, spanning across the globe, ranging from Oman airports, Airport Authority of Oman, London Stock Exchange, MHRA, which is Ministry of Health, Healthcare Regulatory, something like that. I missed out the full form, from UK. Airbus, one of the very prominent space holder in aircraft manufacturing, the India division of Airbus, R&D division of Airbus. Work with KPMG UK, AWS UK, Deloitte, HSBC, and many others. Reliance Jio, one big corporate in India. Okay, this is about me. Now I will switch my screen and talk about what are the do's and don'ts, what are the guidelines for you to join and work on this session. Okay, quick guideline, not very brutal, but it would really help each one of you. If you follow that, if you follow these guidelines, it will create very good experience for you and for others. So I would really request all of you to please adhere to these guidelines. You are very much allowed to ask questions, provided that they are relevant questions. If I am teaching something and you want to ask about that thing, please feel free to drop it in chat. If, let us say, there is a question which is not very relevant to the ongoing topic, maybe you want to ask about something that we discussed in the last week's class. This is our first class, but going forward, maybe there will be a time when you want to ask about last week's session, or you want to ask about a topic which is not being discussed right now. Please hold for that topic for the end of the session. I would definitely answer that question with the best of my understanding, but I would really encourage you to ask that question at the end of the session. If, let us say, for some reason you forget to ask it at the end of the session, or let's say you get to know about that question, the question pops up in your mind after the session got completed, you can drop it on WhatsApp or the email ID that is mentioned here. I hope you have some WhatsApp group and there is some access to you on WhatsApp. You can raise your question there. The question will reach me and I will answer it with the best of my understanding. There are a lot of instructional videos provided to you. Please make sure that you watch those videos while you are going to attempt the hands-on work, the lab work. It would be really advisable that do not conduct a lab experiment in different parts at different time. Start it, work on it, and end it, and then later on clean up all the resources that you have created, because every resource will keep on adding charges to your billing account for every minute of activity. If you forget to keep it active, if you forget to keep it uh, you know without deletion, if it is active for 6 hours, you'll be billed for 6 hours. Nobody would be happy to pay for AWS cloud or Azure cloud or anything when you are not using it. So by the time you are using it, great, you can use that. Maybe you have a free tier account. So in that case, free tier also has a limit. You may go out of the limit and it may bill you up. So please make sure that you delete the resources. Some of the don'ts for you: that don't do hands-on lab while we are in the session. We are here for 3 hours right now. There can be some time when I will ask you to do the hands-on in the middle of session, but do not do that unless I instruct you to do it. So if I instruct you, you're more than allowed to work on that, but otherwise try not to do it. Follow the session which is going on. Focus on this part. I'll show you probably some of the demos and hands-on instructions being executed on my side. Look at the screen. The video, this entire video session is getting recorded. You can always refer back to it while you will be working on your lab on your own. Okay, so the recording will be shared to you in around 2 days of time span at max. Try not to interrupt the session with any unrelated queries over audio or chat. You are allowed to ask the question. If it's relevant, go on the moment. If it's little out of the topic, please ask it at the end of the session. They are very genuine. They are very relevant to execute a great session. And we are good to start. Anything that I miss out on chat, let me quickly check it. Okay, there can be some people who have joined for Azure AI ML program. So as I said you that I, as an instructor, I'm going to take AWS session in depth going onward. But today's class is common for everybody, irrespective of you are from Azure or you are from AWS. Whatever topics we are going to discuss today will also be platform independent. There is a small section wherein we will discuss AWS, and there is also another small section wherein we will discuss Azure. But apart from those two small sections, we will discuss concepts which are platform independent. So I hope this may help a lot of questions on this. Okay. Before I start, I want to take a quick feedback. Is everybody here comfortable with my language, with my accent, with my speed of speaking? Is there any problem? Is my voice very clear? Is my network all fine? Any problem in any of the logistic part? Please let me know. All good, all clear. Thank you. Thank you. Great. So I'll share my screen. There you go. Let us start with these concepts. Before I start with these concepts, if you can speak a little closer to the microphone. Okay, is this a problem with others as well? Is my voice low to you? Voice is clear? Okay, any other group of people? Loud and clear? Okay, Daniel, probably it's an issue on your side, although I have my microphone very close to my mouth. But please check the volume. If still the issue persists, you can drop and rejoin. That may help out. Okay, so before I start with the topic, I have few quick questions to each one of you. First question is, what is AI and how would you be answering this question, by the way? You are not supposed to uh, answer it all at once because that will be a chaos. So what you do is you raise your hand and I will give you unmute access, or I will give you an invite to unmute, wherein you will unmute and speak out about the topic, the answer. Those who know what is AI and what is ML and what is deep learning and what is generative AI, if you know about one or more than one of them, please raise your hand. So let's start with AI first. I have one person raising the hand. Okay. Anybody else? Is everybody aware of how to raise the hand? I hope so. Okay. So I'll give you unmute access. I am not able to hear you.
Hello, can you hear me?
I can now. Yes.
Okay,
I
yeah.
can.
My understanding of AI is, it's basically whereby a software
Mhm.
can, um, where you have a platform anyway, where the software essentially can be used to carry out human behavior and human competencies and things of that nature, right? So asking it a question, coming back with a response,
Mhm.
that sort of thing. For machine learning is kind of like a subset of artificial intelligence, where a machine is basically trained to use, data to make predictions. I hope that's correct. And then deep learning is a step ahead of machine learning. It's also a subset of machine learning, but it doesn't use so much human interaction as machine learning. So that's my basic understanding of it.
Okay. Yeah. Can you give me any simplest example of AI that you can think of? Very, very simple example.
I'll say, using data to make business decisions without human interaction,
Okay.
you know.
Okay.
Mhm.
Let me also try to get some more simpler example than this from other people. What you said is absolutely correct. Okay. So I have also other replies by one by Indeep saying mimic human intelligence, one by Sriram saying a machine thinks on its own and work like human. Yes. Saurav, what is your take on this?
Yeah, Harsh. Actually, like I've been using like as I mean initial days we are using like chat GPTs and all right.
Yes.
So it is like for me, look, I have been so far with this AI tools. Just it is like kind of intelligence giving like whatever we are in giving input as a prompt, uh, they are giving the output actually. So whatever you are giving, I mean, we are using as a tool which can deliver, the prompt response.
Okay. Anything you want to add on as an example?
So like any kind of like I'm my background is like as network engineer, so I've been using tool for some kind of queries and all some error, suppose 404 error or 505 error, what what could be the troubleshooting and all, it gives the everything.
Okay.
Before I used to go and Google and them, and then I'll have to analyze, okay, which is the correct answer, which is the exact or precise answer. But that AI tool helps me a lot to directly come to the point on precise.
Correct. But the solution that you're telling me about is generative AI, which is a very, very niche form, very deep form of AI itself.
Yeah,
And that's not entire AI.
correct.
ChatGPT and Google Gemini are modern products, 3 to 4 years old. And that's what generative AI is. AI as a topic is very, very old. How much old? Instead of answering it, I'll ask people as a question later. But let me take answer from others by then. Abhijit Ghosh. Meanwhile, Srini has sent a message, systems and
Hello,
machines
can you hear me?
performing tasks. Yes, Abhijit, I can. I was able to hear you, Abhijit, but now you're on mute.
Myself. Yeah. So I think you can hear me now, right?
I can, yes.
Wonderful. Actually, I work in the data platform area, right, where
Mhm.
we take care of the machine learning model development, and then we use like in ML, right? When previously when you do the data curation using Hadoop, right, big data architecture,
Yes.
and then we moved on to AWS, right? That is where you use the Redshift, SageMaker, and all. And later
Yes.
on, we moved into Snowflakes, and the other is the Databricks, right?
Correct.
And there you can do the Gen AI side of it by deploying it within its own ecosystem. Then you can do the lineage, you can do the model, like train the model, deploy the model, and make it more interactive from an use
Mhm.
case perspective. And then comes the bedrock, right? So I'm just working a little bit in my area, right, where we are working on some of the bedrock deployments, and then trying to get into integrating that, right, and then the data output, right? So if I am a data, right, with my data is in iceberg format, right, then how that is consumable against the AWS native tools and against Snowflake's the Databricks and across, right, and making it more like cross cloud platform type of a deployments.
But the answer which you said is correct, very relevant, but at the same time, it is very complex for people to understand who are very, very new to it, right? So what I'm looking forward is some very simple example. What we are talking about is AI of 2024, or at least AI of 2020, or AI of 2015, but AI is way older than this.
See, AI, so I'll tell you, AI we started, I started way back in 2001, too, right?
Okay.
As
Okay.
an embedded engineer, right? That is where we have the artificial intelligence to make the chips. I used to do microcontroller, microprocessor programming, right? We used to do
Correct.
the real-time dance sensors coding. So that time, by looking at stuffs, right, it will make itself learn that technique, and it will make itself more intelligent. And next time, it will be more robust when it try to resolve an issue. Learn by its
Yes.
own.
Yes. Pattern recognition, which we say.
Yes.
Okay. Chetan, this is the last response I will take. One last response by one participant. Chetan, what's your understanding of AI, Chetan?
So I mean, I will say it's a field of science. I mean, I read sometime back. It's a field of science which uh, allows computers and machines to have intelligence similar to humans in
Okay.
terms of like the way they take decisions. So
Mhm.
that's AI for me. Machine learning is like the how you teach machines, supervised and supervised kind of learning.
Yes.
DL will be more like neural networks. How you have like how neural networks are being used for deep learning. And generative AI is how you're using AI to create content in terms of images, text, videos, and
Right.
also answer questions. So that's what generative AI will be.
Absolutely, absolutely. Okay, so this, a lot of different answers pointing out the same direction may give more clarity to people. But to add on to that, I will also add my answer. Meanwhile, there is one more answer which is on chat by Siva. A simple example can be an app that can take a photo, image of an ID and capture name, DOB card. Yes, that is what we call as text extraction, or I would put it as object extraction. In the image, you will kind of objectify that this part of the text is name. However, this other text is actually email ID, or the other text is the address, and so on. There are a lot of Aadhaar card scanning tools in India. Those who are from Indian origin must be aware of what is Aadhaar card. An equivalent of that can be a passport scanning tool. If I share you the picture of my passport, because everybody's passport in a country looks same, the regular passport I'm talking about. So you can make systems solutions which can extract information out of it. In a simple way, AI is visioned to make tools and softwares which can eliminate the need of human for all the mundane activities. Very, very simple example can be that if you walk into a mall or an airport or a hospital or a university, you might have seen it often that you walk in, the door automatically opens up, which is based on sensor, and then it closes off when you walk out, when you walk off, right? And then somebody else comes in, it opens up. Now, this is replacing the task of a gatekeeper, which used to exist. It also exists right now, wherever people want to give a human touch. Gatekeepers still exist. They salute you, they greet you, they invite you, they welcome you entering in their property for whatever reason. And they kind of give you a humanly feeling, but that is replaced by AI with the help of a simple sensor. Now, today we think it not to be a technology. We can't call that it's a modern technology today, but it must be a really, really cool thing when it was introduced many years back. I don't know when it was introduced, but whenever it was introduced, it must be a really cool thing that you walk in and the door open up. Another example can be escalators, right? You must have seen in malls, in airports that you are standing and it will automatically take you up one floor or two floors. Now that escalator is kind of replacing the need of humans to walk or to climb up the stairs to put physical strain on yourself. Same thing is with elevators, lifts, and many other tools which are available. Similar thing can be an email which replaces the entire postal mechanism. Nowadays, we do have post offices, at least I'm talking about India. We do have post offices, but that is only used for sending hard copies, sending papers which are very mandatory, but it's not real time. Emails, on the other hand, are real time. They have eliminated the need of entire courier people, courier companies, courier boys and girls, and all the managing stuff. And it's just using technology to deliver the message from point A to point B. And it is bringing very, very new use cases. That's what AI is all about. It is not today's AI. It's a very old format. It's a very old technology. Can you please tell me when do you think AI was launched? Was it launched 5 years back, 10 years back, 20 years back, 30 years back, 1956? Okay, any other answer? 1956 is very old, is it? 200 years? Great. 1980s, okay. 1980s, okay. So, Sriram, what happened to him 200 years? Maybe there was a form of AI, but at least I am not aware of. The modern AI, which we think of, which we see, which we have literature available for, is spanning across the time of world wars. It's specifically World War II, which happened in the time period of 1939 from 1945. Saurav knows AI from last 5 years, but that is not when it was launched. And I'm sure you know it from more than 5 years. I hope you are using YouTube from last 7, 8 years, and YouTube recommends you AWS, sorry, not AWS, Amazon e-commerce. They recommend you the product. Netflix recommend. How old is Netflix recommendation? I don't know, but YouTube's recommendation is very old, much more older than 5 years. So yeah, it was launched during the time of World War, and I will go with slides. I have many slides to show you, but you can have a look here. I'll explain that as well. But it was launched during the time of World War 1939, and it was the one key person in that time was Alan Turing, who was a mathematician, and it was launched for one primary use case, which was translation of language. World War was happening between multiple countries which used to speak, and even now countries like Germany have not adopted English really well. It's still a language difference. So AI was designed in the war period to actually uh, perform language translation and understand the messages of your enemy, even if you somehow trace the message, but you don't have anybody to translate that message. So that is where AI was used, and a lot of other things. It was one of the greatest multidisciplinary research. I am currently pursuing my PhD in generative AI itself, and my guide and my entire university staff, all my coordinators, stresses a lot about multidisciplinary research. What is multidisciplinary research? That you combine two different area of work and then you bring a research of that, which is very revolutionary. For example, uh, medical imaging. You have tools which can look at the image of your X-ray and give you a commentary that what is right and what is wrong. So it's a combination of computer sciences with medical sciences, right? It's a multidisciplinary research. AI was one of its own kind, one of the greatest multidisciplinary research done by mathematicians and logicians back in 1930s to translate language. So there was a language science involved, there was a maths involved, there was a lot of other things involved along with computer science. To be fair, initial people who worked on AI were not even computer scientists. Computer science as a topic came much, much later from that. We have machine learning as one of the subset of AI, which says that I can implement this with the help of statistics. Where we talk about pattern recognition, we are not talking about the core AI. Machine learning is something which talks about pattern recognition. One of the participant here, I forgot the name, but one of the participant gave an example that we can use AI to do something and then learn from the pattern, and then next time it will do better. That's what machine learning is. It's not entire AI. The other forms of AI, the initial forms of AI, are very much driven by logic gates. You might have heard of AND gate, OR gate, NOT gate, if then statements, and a lot of other mechanisms. But when you plan to use statistics and probability and data-based solutions for implementing this AI, you are falling in the subset of machine learning. Go beyond machine learning, there is one theory which says a single equation is not enough to find the answer to a question. For example, can you tell me what is my weight? By asking me 20 questions, probably you can. You can ask me my height, you can ask me my gender, you can ask me which country I live in, because people in different countries have different age, height, gender, weight, distribution. So that may help. You can possibly ask me if I do work out or not. You can possibly ask me if I follow a sport seriously or not. How many hours do I spend on sports or gym or any physical activity? You can ask me probably how many calories I take. And based on that, you will have a ballpark number that this is my weight. Now it's a simple equation. Maybe not so simple, but it is simpler to the other equation, which is, can you tell me if I will get a job next year or not? That is a complex scenario because there are a lot of things which are supposed to be taken in account. One big thing is my profile, my ability to learn, the time I am devoting to upgrade myself as a person, as a professional, as a trainer. Even now, I learn a lot of things as I learned generative AI over past few years because it is launched newly, and there are a lot of things which are getting launched. So my ability, my intention to learn is going to be one thing. But at the same time, you also have to look at market. What is the market scenario? Is there any recession going on? Will there be recession next year or not? Will we go out of recession and move to a progressive economy? Is there any chance of COVID or anything equivalent happening again, which can induce lockdown or similar activities, wherein no matter how skilled you are, you probably may not have a job because the entire market is shut. etc., etc. What kind of sector I am working in. If I am, let's say I am an electrician, my job will be going to get highly impacted if there is anything like COVID introducing up. But as a corporate trainer, as an IT trainer, maybe my job will not be impacted that much because I have most of my work being executed remotely, like this plus. I'm sitting at my home, you're sitting at your home. So COVID may not impact this kind of workflow. If I'm a YouTuber, my job may not be impacted. But if YouTube shuts down, my job will be completely gone. So a lot of things. That's where deep learning comes in, which is instead of making a single equation based out of stats and probability, we will make multiple equations. We will make a depth of equation, lot of equations working in sequence. We will divide the task into different subparts, and we will have multiple processors working on those subparts. Can you see the dot 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 structure on the left side of the word deep learning? That is the neural network. Every single circle you can see here is going to process some part of information. So we divide the processing in different zones. And when you combine all of them, you get a final answer. That's what deep learning is all about. And it is used for complex scenarios like image recognition, speech recognition, topic modeling, and many others. Now, this neural network is again further enhanced, and we get a type of neural network called as transformer neural network. Right? Transformer neural network, which was introduced somewhere around 2014 to 2018 in different research papers. Now, that transformer neural network was designed to do some sort of encoding and decoding, transform one form of text to another text, which gives birth to a study called as generative AI, with which we are able to generate images, generate text, generate videos. We may be able to generate music. If it's happening right now or not, I don't know, but it definitely uh, going to happen in the near future. That we'll be able to generate as many things, as much variety as we want to, and as much as we can. It is happening now, yes, I've heard of it, but how much precise is that? For example, video generation as of now is not that great. You can look at a video and you can find a lot of flaws in that. So it may improve over time. It's hardly 2 to 3 years old technology. Maybe in your entire lifetime, you are learning something which is 2 to 3 years old for the first time. Whatever you learned otherwise, maybe you learned Python, which is a topic of 1985. It was launched in 1985. You learned C++, Java, Android. They're very old. So generative AI is one of those things which are being implemented and people are learning it hand by hand. So over a period of time, it will improve quite a lot. But yes, possibility is always there. We are witnessing those possibilities being executed. Okay, so I hope this gives you a good clarity on what these concepts are. We can have a look at these different points. So definition, we discussed. Each one of them is a subset of the other parent topic. What is the scope? AI is mainly rule driven. Wherever you have rule based system, for example, calculator. Can I say calculator is a form of AI? Yes, I can. It can execute a rule for me. It can eliminate the need of an accountant, maybe. What if I have a calculator to calculate my income tax? It can be a very well replacement for my CA or for at least one job of my CA. So that is a form of AI, artificial intelligence. Android is not that old, 2007, but yes, I don't think so. Many people learned it in the phase of 2007 to 2008. People started learning it when it became really popular. It was not as revolutionizing as it is. Scope of machine learning is it looks at data and it tries to make a model from learnings from the data. Same with deep learning, but for more complex scenarios. Generative AI is something which focuses more on the generation part. And I want you to read the further things. I'll give you 2 minutes for this. Okay, quick question. Are you able to see the bottom line types of tasks? Are you able to see the entire line? Because I have this pop-up of Zoom here. I hope it's not blurring out the content. Great, great, great. So read out this. Take a minute or two. Please explain neural network. Okay, sure. We have further slides and detailed discussion on neural network, but I'll give you a one-liner idea on that. A neural network is a collection of neurons, right? It's a network of neurons. Now, what is a neuron? A neuron is something which can process one small part of information. So what you do is you assign every neuron a different task. And let's say there's a complex problem. That complex problem is divided into 200 small parts. And there are 200 neurons processing it parallelly. And then there is next set of neurons which are going to process it further. So it's like a pipeline. So from input to output, instead of a single equation, as in the case of machine learning, deep learning introduces multiple neurons. Each neuron has its own equation in a way. Same as threads? No. So threads is just a way to execute parallelly, which is what is happening in DL for sure. But apart from that, threads do not take decisions. Right? So in deep learning, every neuron takes a decision. And based on a lot of decisions together, you get the final output. I have multiple slides going further wherein this topic will be more clearer to you. So the common point between threads and neural network is parallel execution. But there are also other things in neural network. Okay, we will proceed further. I guess, so just I want to highlight this point that there are a lot of slides which are written with a lot of text. It may not be very relevant for me to read this text because we have already discussed this. These slides are here because the same PPT will also be uploaded to your school platform, and you can read the same slides from there. Right? So these slides are here for you to read it, not for me to narrate it in the class. This is additional information or maybe same information, which is what we are discussing. What does GenAI uses? So it uses neural networks behind the scene. There are specific types of neural network like transformer architecture. There is something called as attention mechanism. Based on all of those technologies, the modern day neural network technology, which was introduced post 2015, we have generative AI as a capability with us. Where LLMs are used in GenAI. Okay, so good questions coming up. I would be happy to take these questions. LLM is large language model. Now, when you interact with a product like ChatGPT, what you are doing is you are interacting with a model behind the site. What you interact with is ChatGPT. But behind ChatGPT, there are models. You might have heard of GPT 3.5 or GPT 4 or GPT 4.0 and many others. There's a model called as Da Vinci. Amazon AWS has a model called as Titan. Google has another model which is launched for Gemini. So all of these, Meta, which is the parent company of Facebook, has a model called as Llama. These are LLM models. This model is what gives you a text-to-text capability, that you can ask a question in text and you'll get the reply back in text. Are ML and DL used to build model? Yes. DL, which is also a subset of ML, is used to build LLM models, complex models. Okay, we will come to these high technologies in a while, today itself, in another probably 1 hour, but let us go in a flow. And maybe most of your questions will be answered while we will reach that particular slide. So I would suggest you please read these slides when it will be uploaded to school platform. Good slide to look at. It says, what is a model? What's a model? We are using the word model quite a lot. So model is an artificial brain that we are creating. It is trained or it is created based on a lot of data, and then it can be used to perform some operation. In the example you can see on my left side, the example says there are a lot of images of trucks, and there are a lot of images of airplanes, which you are passing to the model, and it can identify whether a given image is a truck or a plane. Now, what is a model? If I give you a more simpler example, if I invite you to my home and you stay with me for a period of 1 week, you kind of understand how the home is, how the house is, and what are various details of the house, how the society is, and how expensive or how economical the market is around my house. Based on that, you can probably guess or estimate the price of the house as an adult. If you have purchased a house in the recent past, then you'll definitely be able to do that. Or maybe a simpler example could be if you look at a car, you can possibly identify or guess make a wild guess that what should be the price of this car based on the brand, if it's Mercedes or Audi or Hyundai or Toyota, based on the size, based on the looks, based on maybe the interior and the exterior and features like sunroof and so on, all of that. You can identify and estimate the price. Can a kid who's 5 years old identify the price of a car? Most likely no. Or maybe for everybody it's a no. The reason is that kid is not trained on that data. You are trained on that data. How are you trained on that data? Throughout your life, whatever your age is, 30, 35, 40, maybe 25, maybe 50, whatever your age is, at least for 10, 15 years, you might have seen a lot of cars, and somebody in your family or in your friends might have told you the price of the car, or you have Googled it. Maybe you have purchased a car for yourself. That is a good data collection. Okay, maybe you have purchased a lot of cars. Maybe you were in the business of car dealership. Then you can identify the price much better than an average person like me. Now that brain, which is trained on a lot of data, is equivalent to a model. That's what a model is. That we will train the model with a lot of data and make it behave like an adult or mature person, which can perform a specific task. As a human, we have been trained on a lot of things. So I, as a person, can perform a lot of tasks like I can play tennis. I can teach you what is machine learning. I can identify the price of a car. I can maybe talk to a person who can speak English or Hindi and many things. But a model is usually designed for a very specific task. It can be designed to classify types of vehicles, as you can see here. It can be designed to identify the price of a house or price of a car. It can be designed to group a given image or a given data into one of the three categories, and so on. That's what a machine learning model can do. But nowadays, we are moving towards a type of technology which is called as generalized intelligence, right? Or also very commonly called as AGI, artificial general intelligence. Now, what is this AGI here? This is what you are witnessing in ChatGPT. It's not trained for any one particular domain like physics, chemistry, geography, and so on. It can talk to you about physics. It can talk to you about botany. It can talk to you about geography. It can talk to you about computer sciences and a lot more. Right? So that is what generic intelligence is. And nowadays, it is also providing you features to interact with voice and video and images and PDFs and so on. So we are making more smarter algorithms which are generalized for a lot of tasks. We are not making model for a specific task. Just the way we don't groom a human to perform a specific task. A human can do a lot of tasks. That's what models like ChatGPT, GPT, and Titan and Llama are supposed to do. But we will not go to that model. Whenever I say a model, I am most likely referring to a machine learning model. Okay, so deep learning, some of you may have a question on this. You can see your well-created neural network on the right side of the slide. The red nodes, the first layer, every column is a layer, okay? The red node that you can see is where we are going to pass on the input. And the green nodes are where we are going to get the output. It can be 1, it can be 2, it can be 3. Okay, so in between that red and green, there's a lot of processing that is happening. So my input will go through 5 nodes in layer 1, which is designed with sky blue color. Then another 5 nodes in layer yellow, and you can see there are a lot of connections denoted by black lines. And then after all of those inputs and processing, it will go to final output. Okay, now this final output will be much, much better, expected to be much better than a typical machine learning algorithm. And it is used for complex tasks like image recognition, speech recognition, autonomous vehicles. You might have heard of Tesla. You might have used Tesla. Living in India, I have not used it. I have been to a couple of Middle East countries where I have, I have sat in that and I have felt that luxury and felt that advancement in technology, but I have not owned it or used it in India. People who are living in US may have used it, or if you're living in UK or some other country, and if it's there, you possibly have used it. So that is a product of finest scale of AI. What is generative AI? So it is that form of AI which is built on the top of deep learning, specific type of deep learning, which can generate content. Before generative AI, we will only be able to classify one input into one of the 5 categories, or take some input like details of a car and assign a number to it, which is the price. But we were not able to create a paragraph about that car. With the help of generative AI, we are able to create a paragraph which is called as text, or we are able to create an image, or we are able to create an audio, or possibly we are able to create a video. There are multiple models for it. We have GPT models. We have DALI. DALI is for image generation. We have a company known as Runway Research for video generation, and so on. So that is what generative AI is. There are multiple tools offered by AWS and Azure to work on generative AI. For example, AWS offers Bedrock platform, which provides you multiple models. We will go in that depth. Azure, on the other hand, has collaborated with OpenAI. OpenAI is the company which has built ChatGPT and GPT models and a bunch of other things like DALI. So OpenAI and Azure works in collaboration. With Azure, you can access OpenAI models and host it in your own cloud. I got a question, which is ML can also work on patterns of data, then why DL? Yes, good question. ML can work on pattern of data, but it may not work really well if the complexity of that pattern is really high. Okay, so for example, if I tell you some details about a car, can you identify or categorize that car to be economical, mid luxury, or high luxury? For example, an economical car can be something which can take you from place A to place B. It is not something which you own as a pride and say that this is my achievement. I hope you're getting my point, right? Which is more in the lower section, which is not designed to have massaging seats and sunroof and all of that. A mid luxury car can be something that can give you these features like massaging seats. It has higher safety standards. The seats are more comfortable, the interior is more comfortable, the legroom is high, but it is also not something with which a street goer might turn back and click a picture. And a high luxury car can be like a Rolls Royce, or maybe a Bugatti, or maybe a sports car, Lamborghini, or maybe an SUV of Lamborghini Urus or any other, which people will be happy to click a picture with. It's beyond the needs, it's beyond the luxury, it's more in the show off category up to some extent. Now, these are 3 categories. If I give you some details of the car, maybe 5 to 6 things, you can categorize that car into one of the 3 categories. That is what machine learning can do. If I ask you a question that, hey, look at this car and tell me if I take this car for a 100-kilometer ride, which is not too much for a car, any car, right? Every car is supposed to go at least 100 kilometers. So if I take this car on a 100-kilometer ride today, given the current condition, is there a chance of it breaking down? How much chance is there? That's a complex question, because the cars usually not break down, but it also can. So you have to look at a lot of things and a lot of scenario. You have to understand what 100 kilometers, what is the terrain there, what is the weather right now, how old is my car, how often it breaks down, what kind of damages it has taken, has it been repaired quite often, what kind of parts, what quality of parts are used in that, etc., etc. It's a complex scenario. That is where we will use deep learning. Machine learning will answer for this, but that answer may not be very relevant. I hope I'm able to put my point in and you are understanding this. Are we clear, Saurav? Yeah, great. Okay, this is also a question, part of the question. So look at the first row. There are 2 rows on the left side. One is data to manually engineered features to model plus new data and so on. I'll explain that. What you do in machine learning is you pass on the data. You don't pass the raw data, you actually engineer that data quite a lot. There's a topic called as feature engineering, where you scale the data, you remove the columns which are not needed, you possibly add some columns, and based on a very well crafted data, you create a model. In that model, when you put on new data as a question, that model can make predictions. But there are scenarios where the model can be created with raw data, and that capability is offered by deep learning. Because that model is so complex in nature, it can identify patterns from raw data itself, which means it will do all of that engineering on its own. You don't need to do it. You'll pass on the data. The model will identify the patterns from it on its own. And then you can ask new question and it will be able to raise prediction for you. There is a detailed differentiation mentioned on the right-hand side. Have a look at it. I'll pause here for 1 minute, and post that we will take a short break. Those who are new, let's keep this as a rule that every 1 hour we are going to take a break, which is going to be around 15 minutes of time. If it needs to be of 10 minutes, I'll inform you. And we can take a break of 10 or 15 minutes. For now, we can take a 15 minutes break. Get a cup of coffee, hydrate yourself, relax, stretch a little, give some peace to your eyes, and then we will be back in 15 minutes. Okay, but before that, read the difference that is mentioned on the right-hand side. Okay, so must be a rounded time at each of the place. Right now it is 8:30 in my side. And please go back to the slide on the definition for AI. Okay, I'll do that. By the way, you are going to get these slides. Sorry, I was moving forward. Sorry. You are going to get these slides uploaded on your platform as well. There's a very interesting question. I will start with that question. Then we will proceed further. The last slide that we discussed was this. Okay. Great, great. Thank you so much for all the people who are responding back. So the question is by Daniel. I want everybody to look at that question. It says, if I put a DL machine in a dark room with no internet and no contact with the outside world, can it still generate inferences? Can it still solve problems? Can it ask for more data? Okay, what do you think the answer is? Anyone? Now, obviously, I'm going to give my answer. But if there is anybody here who wants to give any answer, please come up on audio and feel free to answer it. I'll take 3 answers max, because obviously, more and more people, it may consume a lot of time, but I want to take 3 opinions. If you are interested to put your opinion on this question, please come. And do not feel like that people will judge you for wrong answers or right answers. Don't feel like that. It's an educational class. Anyone? No one. Okay. Okay, so my answer to this is learning. Okay, Raj said learning data, temperature, and L and P values. I did not understand this, Raj. Indeed said, yes, it is. There are 2 things. Do you want to involve bulky servers like AWS Azure for DL, or you want to on local machine? Yes. Okay, okay. Let me clarify more on that. I sense that this needs to be clarified. Okay. There is also one person who wants to answer this. How to pronounce your name? Is it Ikena? Is that right pronunciation? Ikena? Please forgive me and please tell me what is the right pronunciation. And please come up to answer this.
Yeah, can you hear me?
I can, yes.
Right. Actually, I didn't raise my hand to answer the question. Right? I raised my hand to ask another question. But I would say to answer that question, I've got, zero knowledge in machine learning and AI and all that, but I'll just go off a hunch. I believe it can. So I believe the answer is yes.
Okay.
Because I don't think, based on my understanding with deep learning, you don't need that human interaction. And human interaction in this situation could possibly be, being connected to the internet and all that stuff. So that's my basic understanding and my answer to that.
Okay, okay, sure. Got it. I will take that as a response and I will add it in my response. So I'll come to your question, but before that, let me take this question. And by the way, what's the right pronunciation for your name, if you can help me with it?
Yeah, it's Ikena, so the I is
Ikena.
pronounced as an E. So
okay,
yeah.
okay. Sorry for the wrong pronunciation.
Oh
It's
no,
a
you're
unique
good. It's
name.
fine.
Okay, okay. So let's have a look at the question. You said that if I put a DL machine, so when you are saying DL machine, I want to correct on this part. There is no such thing called as a DL machine. DL, deep learning. You can have deep learning models which are added in the machine, are posted in the machine to work. It's a deep learning model. It's like a function. If you have worked on any programming language, you must be aware of what a function is. You raise the input to that and you get the output. It's like a box, right? Maybe a black box. So you give the input, you get the output. What is happening inside the function is a different task. So deep learning model is like that black box. Now you put it in a dark room, okay? with no internet and no contact with outside world, can it still generate inferences? It can generate inferences if you somehow can give input to it and trigger that function to work. Okay, so the function will only work when it will be triggered. If it is not connected to outside world at all, it may not get triggered. And if it is not getting triggered, it will not generate any inference. Because for inference, you need to give input. Inference is the output itself, which will be generated. Can it still solve problem? Yes, internet is not one of the required thing for an AI model to work. And one of the participant has also answered it later that if you are using AWS models or models hosted on AWS or models hosted on Azure, then definitely you need internet to connect with AWS or Azure. But I hope you're talking about traditional deep learning models, which are built on Python or any other language. Usually Python is used for that. In that case, neither we need internet, nor we need any outside world connectivity, but we need to trigger that particular model with some input, and that input will lead to output generation. And this entire process of converting inputs to outputs is called as problem solving. Right? That is the problem itself. Can it ask for more data? No, no deep learning model is allowed to ask for any more data. Okay, deep learning models take the input and produce the output. The input is usually in fixed format. Now, my understanding is maybe your question is coming from the background of Chat GPT, that it can ask you questions and then it can generate answers. That is a very specific form of deep learning called as generative AI. Right? Traditional deep learning models are there to categorize the input into one or the other category or produce a number as a price or as an age of any picture that you are sending or any information that you are sending. So the format of input and format of output is pretty fixed. It cannot be changed. I hope my answer is making sense to you and it is clear. And if anybody else also has any derivative question on this, please let me know. Okay, Ikena, I'll move to your question. Ikena, I hope you're able to hear me.
Okay, yeah. I was still on mute. So, as I said, I've got, zero experience in this whole thing. I was looking at, well, while we're on break, I was looking at the definitions here to, difference between deep learning as well as machine learning.
Yes.
And where you have applications, the one at the bottom, you said deep learning is used for autonomous vehicles.
This one?
However, in the previous, no, if you go back to the slide you were on,
Yep.
the other slide, the one you were on first when I started talking.
Okay.
Yeah. So this one. So you said deep learning at the bottom there, the applications. You said deep learning can basically use for autonomous vehicles and all that. However, in the previous slide, where you have the definitions of AI, machine learning, GenAI, and the rest of them, in that one, if you can scroll up one, I think one or two more slides, and I'm trying to understand this because it's a little bit confusing.
You're talking about this. You have self-driving cars here in AI.
So why is there a disparity there? Because already you're saying artificial intelligence does self-driving cars, which obviously would mean autonomous vehicles.
Yes.
Why is it the same thing?
Yes. So the answer is in the same slide. Look at the first line of scope. Second paragraph, scope, which says AI is the broadest category and ML, DL, and GenAI are subsets of AI. So whatever ML can do, like we can say ML is also AI, DL is also AI, and GenAI is also AI. And second part of the answer, I want to show you with this Venn diagram. So if deep learning can solve something, we can also say it is solved by AI, because deep learning is one subpart of AI itself. Right?
Gotcha.
It's not a different thing. It's altogether a part of AI itself. However, vice versa is not true. Maybe there is something which AI can do. It may not be happening with deep learning. Maybe it's happening with machine learning. Or maybe it's happening with rule-driven programming or fuzzy logics, which are different things, which are older technologies before ML was introduced.
Okay. Makes sense. Yeah. Thank you.
Thanks. Okay. And I have also looked at chat. Indeed has shared a very beautiful example for answering Daniel's question, that I have Indeed said that I'm using this in one of my projects where I'm detecting fatigue level in driver using tracking eyes. Right. So you may have a camera mounted on the dashboard of the truck, which is capturing face of the driver. And based on that face, you are giving an attention score that this driver is 90% attentive or 80% attentive or has very high fatigue, something like that. So you're generating a number. Is GenAI the only subset of deep learning? Answer is no. There are many things which are happening with deep learning itself. For example, self-driven cars. Generative capabilities are one, self-driven capabilities are another. Image recognition or image analysis, that is also happening with deep learning. Speech analysis is also happening with deep learning. Why generative AI is highlighted? Two reasons. One, it is very booming. It has the highest boom among all the list topics which are listed because the use cases are very high. As a IT person, I have the ability to use deep learning, but maybe those who are not from IT may not be able to use deep learning at all because you need to learn Python, you have to learn Azure, AWS, etc. At least one of them to work on this. But generative AI, on the other hand, is something uh, which has launched ChatGPT and tools like that, which can be communicated via simple English, right? And everybody, my wife, who's a social media manager who has no experience on Python or other machine learning or statistical technologies, is using generative AI. Somebody who's a doctor is using generative AI. Somebody who's a student or somebody who's a teacher is using generative AI. No matter if you are from finance or healthcare or any other field, if you can speak or write English, that is enough, and it's one of the modern technology. Another reason is it is also part of this course. So as a part of the course, it is highlighted that where generative AI is standing in this entire landscape. It is constantly changing. What is the status? So as the answer in the question itself, it is changing quite a lot. As of now, we have multiple models and projects which are able to generate text, multiple projects which are able to generate images, multiple projects which are able to generate videos and sounds. And generative AI is introducing new topic. I wouldn't say new because it is still a few months old, which is a lot given the entire history of GenAI. It is agent-driven analysis. Now, I will not go in the depth of what is agent-driven analysis. If you are interested, please search this, and the right term to search will be React in generative AI. Okay, this is not React JS or React Native, which is a front-end technology for those who are developers. This is not that. It is a different thing. Intentionally, E is small in the entire word React. Please read about what is React, and it is very fascinating. Okay, so let us see a difference between traditional programming and machine learning. In traditional programming, we have inputs, we create our own rules, and we produce output. A simple example of that is you go to a grocery shop, you purchase something. Let's say I purchase, milk, and the grocery shop owner will give me some sort of insight that do you also want curd? Do you also want cheese? Do you also want some other dairy product? So kind of a similarity analysis is done by that grocery shop owner and producing output. Now it is very good provided that there are limitations of this. First limitation is you can only do it when your number of products are maybe 10, 20, 30, 40, 50, not when your number of products are 5,000. Second, you can only have generic rules. Maybe most of the people like to have curd when they purchase milk. I am a person who don't like curd, who don't like to eat curd. So maybe recommending curd to me will not be a really good idea. So can that shop owner understand profile of the customers? Yes, if there are 10, 15, 20 customers. But if there are 20,000 customers, that person cannot understand the profile of everybody. So you need to look at other solution for recommendations and various other problems when you are going out of scale. That's where machine learning comes in. This is how when you purchase something from Amazon, it recommends you recommended products. It tells you what other people of similar profiles are buying. Nobody is sitting in Amazon which is sending you email of recommended products to buy. It is the algorithm. Given that they have millions of consumers, there cannot be a staff member who can drive insights for millions of consumers. It needs to be a machine. Similarly, let's say you get a box of shoes and you have to categorize it to be okay, let me change my example. Let's say you have 5 cars. You're living in a large family, there are 10, 15 people, and you have 5 cars. Now, if you have 5 cars, you have to identify those cars to be luxurious, super luxurious, above average, above economy, so to say, and economical. It is very easy for you to do that because there are only 5 cars and they are not changing. But imagine I run a website wherein I have 20,000 cars listed, and it's a platform where anybody can post a picture and details of their own cars. Now, I can't sit on my website throughout the time and categorize every new car uploaded to be one of them, manually looking at it. I can, but it will take a lot of time, and I might have to hire more people to do it. But if I deploy a software which can understand what is luxurious, what is super luxurious, what is above economy, what is economy, then that will be great. Whenever you upload any car detail, it can categorize that I will categorize your car to be super luxurious, or I will categorize your car to be above economy, and so on. That is what rule is. So this rule is driven by data. That is what we say as pattern analysis. Please read the table on the right hand side. That will clarify more on it. Okay, moving ahead. So this is an example of traditional programming that you have some inputs, people of different age, different genders purchasing something on given dates. So you can write down rules. But then can you write down rules for millions of transactions or thousands or millions of consumers when you have a lot of different types of products? No, rules cannot be written for that. So that is where you need some sort of model to generate insight. And this is that model. You had some data, historical purchase data. You pass on the data to some learning algorithm, which is what we call as untrained model. That learning algorithm will understand patterns from it. And after understanding pattern, you get a model, which is the artificial brain. Now, when you give some input to that, it can make predictions based on the pattern. That in the past, similar details ended up purchasing books. Similar people ended up purchasing toys. Similar people ended up purchasing mobile phones. So that is what recommended products for these people can be. Please interrupt me if there is any question. Drop it down on chat. You should not use machine learning for every scenario. Whenever your scenario is simpler or it is rule driven, do not choose to use machine learning. Let me see if I have a slide for that. I don't have. I don't have a slide for when you should not use machine learning, but I'll explain it on the voice. For learning algorithm, we need to feed input data and output data. Yes, we need to give past data, which will have input and output. This form of learning is called as supervised learning. There is another form of learning called as unsupervised learning, wherein you will only give input data because there is no output data that exists. I'll give you example of what are they, but later on in the course. It may confuse other people. So you need to give data. What type of data you give decides what type of training you are going to conduct. Okay, coming back here, when you should use machine learning, before that you should also know when you should not use machine learning. So my question to you is that I have certain income sources. I earn certain amount of rupees. Living in India, I earn rupees across the year, and I have some tax liability on those rupees. So my question to you here is that if I want to have a software which can tell me how much tax I have to pay, should it be driven on machine learning? Should it be built with machine learning? Type down yes or no on chat based on your understanding. I want everybody to type down that answer. Should I use machine learning to solve a problem? The problem is I want to have a tool which can calculate how much my tax liability is this year. One of you said no, one of you said yes, then more no's, more yes. Mostly there are no. But then Daniel said not really. Traditional programming should be able to suffice exactly. Because in most of the countries, I hope so. At least in the common countries where you people are living in, US, UK, I'm from India. Sweden, I don't know, to be honest. Even if there is a tax in Sweden or not, I don't know that. But basically, there are fixed rules. That for initial, in India, the rule is from 0 rupees to 3 lakh rupees, you don't need to pay any tax. 3 lakh, I guess everybody is from Indian origin, but those who are not, 3 lakhs is 300,000. From 300,000 rupees to 600,000 rupees, there is a 5% tax. From 600,000 rupees to maybe 900,000 rupees, there is a 10% tax. I can be wrong, but this is how it is structured. And there are certain rules that this amount will be not considered for tax. So there is no pattern matching in this. You need a simple calculator which understands these rules and can ask you right questions and then generate answer for filing. But yes, for analysis and suggestion, yes, that is where machine learning comes in. Now, another example where you should use machine learning is if I tell you that, hey, this is my profile, this is my years of experience, my education, these are the companies I'm working with as a trainer. Tell me how much money I'll make next year. So if I ask this question to 20 people, everybody can have different answer. Coincidentally, that can also be same, but it can have different answer. There you will analyze the pattern of my past year's earning. You will analyze, am I growing or am I stagnant? Is the industry growing or it is stagnant or it is declining? Is there any chance of this industry rising really high or declining really low in the next year, and so on? So that's where you will analyze pattern, and that's where machine learning or probably deep learning comes into picture. If you want to carry out predictive analysis, you should use machine learning, absolutely. But for simpler scenarios, you should not. So whenever you have problems which involve lot of patterns and lot of variability, for example, let's say, you have to find out whether a particular student will pass or fail the given exam. So there are a lot of patterns in that. Two people who are studying the same amount of time, reading the same books, sleeping at the same time, eating the same food, taking the same coaching, one of them can pass, one of them can fail. Because there are a lot of other things that, which are out of your control, like how their brain works, how much they are able to understand, how much they are able to retain out of that information. Do they think practically or not? So whenever you are in such type of scenario, you should use machine learning. If you want your solution to scale, you should use machine learning which can automate human tasks, like that grocery shop recommendation. It is good to be recommended by human when it is a grocery shop, but a company like Amazon, which is really large, should not use human assistance because the number of consumers, the number of products you have is really high. And there are many other reasons. Please have a look at that. So use ML when you can't code it. You cannot write the code for how much a person can earn in the next financial year because there are a lot of different things involved. If you try to write down a code, you're making a generic rule that there will be 10% increment. Maybe there will be less than 10% increment for few, and maybe there will be more than 10% increment for few others. Use ML when you can't scale it. You can use human decision making when it's of very low scale, but when you have to scale it to really high quantity, then you need to use machine learning, like spam or fraud detection. Can a human look at an email and identify if it's fraud or not? Most likely, yes. But then do you think Gmail has human team sitting behind the system? Answer is no, because there are millions, if not billions of email transferring through Gmail every day. And a group of humans are not enough for that. You need to have a really, really high number of people, which is a waste of money, waste of resource. Use ML when you have to adopt or personalize, which is what recommendation system is. The way you get recommendations on YouTube, on Spotify, on Netflix, on Amazon. It's a personalized recommendation. It's not generic recommendation that if you watched a particular movie, then the next movie is only this for everybody. That's not the case. Maybe you watched a romantic movie and the next movie you want to watch is an action movie. Maybe some other person who do not like to watch an action movie may watch some other type of movie. So that's a personalized recommendation. And it is also related to scale. If you only have 5 users for your platform, you can provide personalized recommendation to them as a human. Let's say I am teaching you for next 6 weeks. Right? Over 6 weeks, I will kind of have a strong understanding for at least 10 people out of you. And I can personally suggest that, hey, given the type of person you are, you should spend more time on reading books rather than watching YouTube videos for learning. But I can't do it for 10,000 students. That's where personalized recommendations comes up with ML. Dynamic pricing. For an airline price or a hotel price to be decided, there are a lot of factors which include demand, supply, any war going on, any festival going on, etc., etc., which cannot be hard-coded by simple piece of rules. So that is where machine learning comes into picture. Use ML when you can't track it. If there is unpredictable scenario, if there are autonomous tasks like self-driving. So you don't want that the input should go to human and the human takes decision and apply. That's what human drivers do. That's what basically we do while we drive the car. But autonomous system is built on ML and it is replacing humans or assisting humans as of now. I should use my words carefully. As of now, it is assisting humans, but in future, it can replace humans to drive the car. Okay, are we very clear so far? Because next topic is very different. It's more mathematical, it's more scientific, and I will have the discussion. But is there any question till now that you want to ask? Anything that is not clear to you and you want to ask that? So if you want to, okay, well, that's an older message. Nothing for now. Let us talk about algorithm. So what is an algorithm? Something is a message. Hold on. Very good overview, no questions. Thanks, Daniel. So what is an algorithm? Basically something which takes a lot of data, understand the pattern from the data, so that that pattern can be used for predicting future. For example, I understand my sleep cycle, and because I am tracking it from a long period of time as a human, maybe everybody is doing that. So when I'll go to bed today, 10:30, this class will get over. If I go to 10:30 at my time, 10:30 p.m. When I'll go to bed at 11, I'll have some understanding that I can't wake up at 5 a.m. tomorrow. That there is some algorithm in my mind, intentionally or unintentionally, which is working up, taking the inputs, applying it, applying past patterns on that. There can be few people who can wake up early in the morning, no matter what time they sleep. So if let's say you are that person, you will say that, okay, even if it's 11:30, even if it is 2 a.m., if I sleep now, I can wake up at 5 because my body wakes me up at 5. I can't sleep after 5. You have a different pattern. I have a different pattern. And if I give input along with the pattern, an output can be found out. This process of converting input to output mathematically is what an algorithm is responsible for. What does it do? It assigns individual weightage to every input. You can see an equation on the bottom that there are two components. One of them is written with A's, A0, A1, so on. Other one is written with X, X0, X1, and so on. To explain this A's and X, I'll give an example. You have to identify the price of the car that I am driving. And you can only ask me 5 questions. What will those 5 questions be? Can you type it down on chat? You have to identify the price of my car, at least an approximate price. Okay. And you can ask me only 5 information about it. Please put all the 5 questions in the same message because it will come up from multiple people. One of you said model, one of you said brand. Chetan said make of the car, model of the car, year, color, features. Okay. Make, model, year, mileage. Price of the car, great, but that is what you have to figure out. So obviously I'll not give it to you. If I know the input, if I know the output, why will I make a software to get that output? Maybe I know it for my car, but I want to make a system which can predict the price of any car walking on the road, riding on the road. Tax bracket of the car. Okay, that can give you a good idea. Country manufactured. Why nobody asked color of the car? Same car, same brand, same manufacturer, same year, same tax bracket. One of them is white, one of them is black. Will the price of car change? Yes. How much? Because very less dependency on the color of the car on price. Exactly. So even if the price will change, why you did not ask what is the seat color? Do I have seat covers or not? Color is not a big way. Exactly. Exactly. The importance that you are giving to these features is exactly what is called as a weight, right? Weightage, which you can see as A0, A1, A2. And the questions that you asked Let us say I take question of Sriram to pick one instance out of you. So Sriram asked brand, manufacturing year, features, build quality, safety rating, and next is fuel or electric. So there are 5 points. Each of them is X, X0, X1, X2, X3, X4. Each of that will have some weightage. The price of the car will change drastically if I say that my car is of Toyota or of Mercedes or of Rolls-Royce. Then any of the other thing will not be of higher importance than the brand value. Manufacturing year, a Mercedes of the manufacturing year 2010 can still be little expensive than a very economical car which is of 2015. Right? Other things will also not matter quite a lot. So weightage is what you assign to every feature. Manual or automatic, that can be one of the feature to look at. So I hope you got the idea. There are a lot of things which are not of higher weightage. That means the value of A for them will be really low. Like, do I have seat covers? Do I have, is my car vacuum cleaned or not in the last week? That doesn't really decide the price of car. It can change the price of car by hardly a few rupees or a few dollars. Right? So if let us say X1 is if it is fuel or if it's a fuel car, if it's having a diesel engine or a petrol engine or it is electric, price of the car in Indian economy I'm talking about can change by possibly 10-15%. But the brand name can change the price by a really, really high volume, more than 100% for sure. Then if it's having a sunroof or not, same car, two different instances, one with a sunroof, one without a sunroof. The one with sunroof can be probably 1 lakh rupees expensive, the new car, right? If it's having automatic wipers or not, that may change the price by a very lower quantum. That is what weight is. In machine learning, when we are designing an algorithm, we are designing the algorithm to automatically assign weight to every input which we are going to pass in. How will it assign? Based on a lot of data. If I give 500 cars and their pricing, details of 500 cars and their pricing. So model will somehow figure out that if I have same car, 3 instances of same car, one with white color, one with black color, one with red color, the price is not changing by a significant amount. However, if I have 3 cars with same manufacturing year, same colors, same set of features, but the brand names are different, the price is changing drastically. So weight of the brand name should be much, much higher than the weight of anything like color. That is what an algorithm is supposed to do. Are we clear till now? It is complex for people who are hearing machine learning for the first time. But this is the core of machine learning. Same thing is implemented in deep learning as well, but with little more complexity. This is one layer of processing. When you replicate this one layer of processing and make 20, 30, 40 layers of processing, that's what we call as deep learning. And those 20 layers are connected to each other with some other mechanism that we will discuss when we will come to neural networks. Is the weight subjective or objective? I did not get this question. But if you are asking, will this weight be constant? Yes. The weight will be observed from the entire data and there will be one final weight. Let's say you give 500 cars as their details and the price. So the model will figure out one final weight for brand name, one final brand weight for color, one final weight for another column, maybe manufacturing years, and so on. That is the reason machine learning's predicted answer may not be accurate because it is generalizing the entire information of 500 cars. So it may not produce the same answer as you have already passed it. On what basis weight is determined? On the basis of variance. So because you are giving input and output both, machine can figure out which column. Imagine all of your questions as columns. Which column is creating highest impact on the answer? Is it brand name? Is it color? Is it seat cover? And then how much change it is creating. So machine, based on a lot of data, the model will figure out that change in brand name is changing the price by many, many hundreds of thousand rupees. However, change in color is only changing maybe a couple of thousand rupees. So the variance of that is very different. So color is not as heavily weighted as brand name. Now, obviously, I'm teaching you conceptual understanding of it. All of this is driven by maths, which works under the skin, right? So you run it for 20 times. Every time the answer of that weight will be same. So maybe this is also answer to your question, Daniel. It is objective. You run the model 20 times. Every time you will get the same weight and same prediction because it is driven by mathematics. It is not driven by assumptions or opinions. It's a mathematical process. Machines cannot make assumptions, cannot make opinions. Are we clear? Any question? Okay. Now here I will highlight one more thing. This is the reason why you have to convert all your information to numbers, numeric format before you pass it on to machine learning. You might think that in ChatGPT we write down English. That's a different thing. But if you talk about core machine learning or deep learning, I will come to why we can write English in ChatGPT. That is a different thing altogether. But in the core machine learning or deep learning, which used to exist before 2018, I mean, it still exists right now, but whatever was there before 2018, in that we have to put every information in numbers. Even if your brand name is textual, like Mercedes and Audi and Ferrari and Toyota and Hyundai, these are English texts. Color of the car is white, green, black, red, yellow. It is an English text. It needs to be converted into numbers. There are multiple mechanisms for that, which we call as encoding, which is a part of feature engineering because the mechanism is working on numbers itself. Mechanism cannot differentiate between a Hyundai and a Mercedes and assign weights to it. It needs to be converted to numerical format. So coming to next question, that why we can pass English text into Chat GPT. Even if you are passing English as a text, it gets converted into number internally, which is the process called as encoding. The output also is generated in numerical format, and then it gets converted into English to show you. That part is called as decoding. Now, this encoding plus decoding is what is made possible by transformer architecture, transformer neural network architecture. Before that, we did not have this capacity. Okay, a quiz time. Question number 1. What differentiates GenAI from traditional AI model? Simple question, easy question. Drop your option choice A, B, C, D on chat. B by most of you, which is also correct. The differentiation lies in generation capability of generating information. It cannot learn without data. It only works with supervised, but yes, non-generative AI models also works with supervised learning as well. The generative AI do not work in supervised. It works on self-supervised, which is a different structure altogether. And it uses decision trees? No, it does not use decision tree. There are other algorithms. It uses transformer architecture with attention mechanism. You don't need to remember that, but it does not use decision tree. Okay, we'll move to types of ML. One of the participants here also said that will we pass input and output both to model? That depends on what type of learning you are doing. So let me go to various types of machine learning, and there are many types, and there are many subtypes. Three most common types are supervised, unsupervised, and reinforcement. There is also many other types like something called as semi-supervised learning, something called as self-supervised learning, but they are not as developed as these three forms. Out of these three, the most developed one is supervised. Second, I would rank is unsupervised, and the third I would rank is reinforcement. But each one of them is highly developed as of today in an absolute term. So what is supervised learning? Let us expand more on that. You can see that each of that type also has various use cases assigned to it. Supervised can perform classification and regression. What is classification? What is regression? We will talk about. Unsupervised can perform clustering. Reinforcement learning can perform decision making or process execution. It is mainly used for game-based scenarios. Like you might have heard that we have AI models which can play chess, which can play other board games like Go game. We have AI models which can drive car as Tesla is using. They are primarily driven by reinforcement learning. So let us get in depth of that. Let's talk about supervised learning. It is that form of learning wherein we are passing the input and its corresponding output. And we are passing this data, this pair of input output, hundreds or thousands of times. As an example, you can see on the left, there is a bulk of data. There are only 6 examples shown, but imagine it to be thousands of records where there are images of various animals and it is assigned a category of cat or dog. The model will learn that what is similarity between all the types of cat and all the types of dogs and what is the difference between them. So that when you ask the model that, hey, look at this new image and identify it to be a cat or a dog, it can identify that. That is what supervised learning is. This example is of classification. Another example for regression is you will pass a lot of car details to the model along with the price. So you have 1,100,000 records, 100,000 rows, where there are 10 columns. One of them is about manufacturer, one of them is about launch year, one of them is about safety rating, one of them is about number of seats, and so on. And there is last column which says price. The model will learn that, okay, does number of seat impact price? If yes, how much? Does color of the car impact price? If yes, how much? Does city of purchase impact price? If yes, how much? Right? That will not be a really high difference in the same country. And that is what regression is. You can read about regression and classification on the right side. It's a one-liner definition with some example. So we talked about what is ML, supervised ML, supervised machine learning. There are multiple algorithms which follow supervised learning. They are listed on the right side. You don't need to remember them. We will talk about them when we will go forward in maybe day 3, day 4, not in this week, not tomorrow, not today. But going forward, we will implement those algorithms and we will see how they are different or similar to each other. Then there is unsupervised learning, wherein you do not pass output because probably you yourself don't have output of that particular data. It is not a data where an input-output relationship is needed. It is a data where you have to perform maybe clustering. You have to assign different groups to the given data itself. It is not same as classification. For example, let's say you are a city planner, you are a city planning officer. You are assigned a city where you have to launch a rapid metro. I hope everybody understands what is a metro railway network, right? I'm not really sure of all the other countries, but in India, we do not have metro in every city. It is there in probably 30, 35 cities across the nation, tier 1 to tier 2 cities. There are a lot of new cities where the plan of metro railway network is under execution. Now you have to decide where metro is, subway is tube. Yes, in UK it's called as tube, I guess. Subway, I'm not sure where you call it subway, in US or somewhere else, which is better. Inside the city, when you want a railway connectivity, that is what metro is. Great, Daniel, thank you. So now you are the city planning officer and you have to figure out where should the stations be. So do you have a past data that there was a station in this, there was a metro station or a tube station in this place and it was a successful station or not? No, you don't have a data because this is the first time you're executing this project, right? And every city is very new, very unique, right? Very differently structured. The dynamics of the city is different. The industrial area of the city is at a different place. Residential area is at a different space. Crowded area is at a different space. So you may not have two cities which have same dynamics. It's very, very highly likely. So now the only thing that you have is data. What type of data? Where are people living? Where are people going for work? Where are all the entertainment centers like malls and movie theaters and all of that? Which areas are crowded areas? Which areas are non-crowded areas? In which roads we have a lot of traffic? So implementing a metro or a subway can actually reduce that traffic, etc., etc. You have this data. Another example can be, let's say you are a telecom provider, a new company, and you are moving to a village where there is no telecom provider implemented right now, established right now. Countries like US and UK, you may not have any village or city where there is no telecom provider. Those who are not able to understand telecom, it is SIM card, right? In India, we have Airtel, which is also there in US and UK up to some extent. We have Virgin Atlantica or some other some other name with the title version in US. And we may also have something like this in UK as well. So you're moving to a village and you have to identify where should you set up your mobile phone towers. You don't have any output to that. You are not in a scenario where you have to find out input to output. AT&T in US, exactly. One of the very old company, oldest if I would say. So this is the requirement which can be solved with unsupervised learning. Another format, we will go in depth of unsupervised by the way. Another format is reinforcement learning. So reinforcement learning is that wherein we have an environment, an agent, and there is reward or penalty. Let me explain that. Imagine you have a kid at home, hardly 2-year-old, 1.5 year, 2-year-old, learning how to walk, learning how to crawl, do not understand what is hot, what is cold, do not understand the meaning of temperature or existence of temperature. Accidentally, that kid goes near the cup of a hot cup of tea and puts the finger in and feels a burning sensation. Now, this is a penalty given to the kid for the action, which intentionally or unintentionally will give kind of a small trauma to that kid, and the kid will never go near the hot cup of tea or would definitely hesitate to put the finger in that. On the other hand, the kid uh, steps on a toy and a button is pressed, which produces some music or some light, and the kid get excited with that, which gives a reward to that kid, and the kid would again and again and again will do that action, enjoy the reward, and keep repeating it. So there is an environment, there are actions which you will take, and you will get reward or penalty. And you might think that what is the real world application in that? There are a lot of applications. One of the application is, imagine you are a chess player. I hope everybody understand simple dynamics of game of chess. So when you take any move in chess, the final objective in your mind is to defeat the other person by capturing king, right? Now, one of your moves may not capture king, but it will be one big move in the entire journey of capturing king. If let us say that move backfired, you realize that, okay, there was a mistake. There was one piece of your which got captured because of your mistake. You did not look at one part of the board. That is the penalty. On the other hand, if that move bring you some strategically successful position in the board, which can later be helpful for you, that will give you a reward. This is how the model will implement a reward or penalized based system. Another example for that could be army tactics. You'll make a tactic. You'll take actions which will give you reward. The reward for you is better strategic positions in the war field. Penalty could be exposing you towards the enemy and maybe giving you a weaker position or maybe bringing you more towards defeat. Trial and error, kind of, yes. Every trial is assigned a number. That number can be positive, which is reward, can be negative, which is penalty. The objective is to increase reward and reduce penalties. Some of the common use cases, I don't think so that I have to explain them, read them out. You can read it. If there is anything that you want me to answer or clarify, I can clarify them. Some common use cases of AI. Okay, there are more. I would definitely suggest you that read through them in detail when you'll be out of this class, maybe tomorrow, maybe day after tomorrow, from your school portal. Okay, a quick overview of how a machine learning process looks like. We start with a business problem. Let's say I'm running a business, and the problem I'm facing with is I hire a lot of people. I'm going through hiring phase. I identify talent. I invite them for interview, or some of the people apply on their own via LinkedIn and other platforms. I conduct their interview. I give them offer letter to some of the selected people. I wait for them to join at a given date, and they don't show up. They don't show up. Right. So my problem is I want to have a mechanism, a software, which can take a person's input and a lot of other input and can tell me whether this person will join your organization or not. Because if I get to know this person is not going to join, I will hire somebody else without wasting any time. So this is a business problem. I'll convert it to a machine learning problem that this is a classification scenario. The classification has two categories: will join, will not join. And I have to classify every candidate into one of them. I'll collect data for that. I'll do all the data processing, integration, preparation, visualization, which we are going to see in this course in upcoming weeks, not today. Once all of that data engineering is done, I'll pass on that to feature engineering. Once my feature engineering is done, I will train my model on that data, on that engineered process data. Once my model is trained, I will evaluate that model if it's doing good or not. Obviously, it's a software. It cannot be blindly trusted. If it does not do good, if it does not work as expected, if it does not meet my business need, I will go back to the start. Maybe I did something wrong in data collection. Maybe I need to collect more data. Maybe I need to do more feature augmentation or some analysis. So I'll do all of that thing again. And then by repeating it maybe 5 times, 6 times, 7 times, I will have a model which is now meeting my business goal. Once I get that stage, I will deploy that model. Now comes to another question which was asked by maybe Daniel. I guess it was Daniel who said that if it's in a dark room, no internet, can it make prediction? Yes. So a deployed model can make prediction, provided it is not, okay, I'll say provided that you are able to give input to it and trigger it. Whether it is by internet or without internet, it does not matter. So it will make predictions. Over a period of time, I will monitor my model if it's making predictions rightly or not. Even now, it's been 6 months since my model is deployed. So is it relevant now or not? If it is not relevant, I'll again start this entire process of retraining. We'll start with data collection, newer data. Maybe the dynamics are changing now. I gave an example in one of the webinar I took earlier. The example was maybe you make a model that how many hours people are spending in a week on physical fitness related activity. Could be gym, could be walk, could be jogging, whatever. Number of hours. So you made this model in 2016 and you got answer for different cities. If I give the name of the city, you can tell me number of hours. But then post 2020, the dynamics are changing. The people post COVID are now more serious towards their health. So maybe the city where people were spending only 10 hours a week, people now are spending 20 hours a week. So for that, you need to retrain your model. Saravas, please explain this overview. Okay, this entire cycle. I have more slides to explain this, which has the same diagram in a different format. Maybe just the next slide. No, I don't have it here. Maybe it's later. So I'll explain it here itself. You start with any business problem. You never wake up and say, today I'll make a ML model. No, that will not happen. You will be having some some business problem, which will derive the need of making a machine learning solution for it. Right? Maybe if you're working in a company, some of your management person will come to you that, hey, we are facing this problem. Solve it using AI or machine learning. That's a business problem. You will convert that business problem to a machine learning problem. Right? You'll identify what type of models, what type of ML, what type of structures can I use from ML on this. You may not know about those structures today, but over a period of this course, you will understand what are various types and executions and nuances of machine learning. Based on that understanding, you will decide what type of problem it is. For that problem, you will collect the data and then prepare the data via integration, preparation, storage, visualization, analysis, engineering, all of that. Then you will move it to model training. If your model does good, you'll deploy the model and you will use that model for making prediction. If it doesn't do good, you can go back from data collection and start the entire process again. That is what a machine learning pipeline or a machine learning process structure looks like. Are we very clear till this? Yes or no? Any question? Would this scenario be a supervised ML? No, it can be unsupervised or reinforcement learning ML as well. It can be for any type of machine learning. You train the model in every scenario, you evaluate the model as well, you collect the data as well, and then you obviously deploy the model and monitor it. So it is applicable to all the types of machine learning. Quiz time. Which type of machine learning uses reward and punishment as part of its learning process? Easy question. C. Many of you are saying C. Great. I got a question. How do you deploy past a Jupyter notebook into production? There are a lot of tools on that. If you are from AWS background, I would suggest you to wait for SageMaker, wherein we will discuss how to deploy the model. If you are from Azure background, we have Azure Machine Learning Studio, which can do the same thing for you. If you don't want to use AWS or Azure tools, you can export a Jupyter notebook into a Python model file. You can save the model as a pickle file and then post it on your own server or on the cloud without using SageMaker or Azure ML Studio as well. So there are multiple solutions to it. Then I got a question, is data preparation the filtering of good and junk data? Yes, it is one part of it. There are a lot of other things in data preparation, like discarding some of the rows, some of the columns, which you said is probably junk data, converting text to numbers, and so on. Can you explain the model deployment, prediction, and monitoring? Okay, I will try it one more time. So model deployment is that whatever model I have will now be accessible to people over some or the other format. Right? What format? It can be over internet. It can be inside an app, just the way YouTube recommends you. So they don't give you recommendations API. Rather, when you watch a video, their model is used to give you next set of video. That model cannot be accessible out of YouTube. Or it can be inside a game. Maybe you're playing Counter-Strike or PUBG or any such game, and they have bots as opponents to you. They may be built on AI, may not be built on AI as well, but if they are, then that is what model deployment part is. Using the deployed model, you can make predictions, and then you will monitor that whether my model is doing good or not. You might have made a model on day 1, maybe on day 100, it may not behave properly. It is out of context. The dynamics are changing, the people are changing, the reports are changing. So for that, you need to again collect data and retrain that model. That answer can be figured out from monitoring and debugging part. So I'll do one thing. I'll open both AWS and Azure because people are from different background. And I'll show you what are the tools which are available with us. And with that, we will wrap up this entire session.
Okay, going forward on that question. So if I, basically whatever the, evaluations that AI ML engineers did, right? If I through no code thing to AWS, let's say either AWS or Azure, if I run, can I validate it to make sure that they're giving the right model? So can I compare based on what they gave me and what models I run?
Your question is, if somebody says my model is 80% accurate, can you run it again and check 80% accuracy?
Yeah, can I run it on AWS no code and run it to see, like, even if it is close to that?
It is a different thing to run a model on no code and on code. I would use on code as a word, which is not a word actually. Basically, a Python based model and a no code model, they are two different things. And executional details will also impact the performance up to some extent. It's not so easy to replicate the same thing with same metrics on AWS. Maybe what you can do is you can read that code and have some sort of understanding whether this code is right or not. One example, one method. Second method can be you can validate that piece of code through tools like ChatGPT and Gemini and say that, is there any forgery in this code? Is there any hard-coded number which is mentioned, which is fooling me around, or is it a genuine code and giving genuine metrics? That can be done. Third example, which you may already be thinking about, can be you can hire an external auditor who's an expert who can give you unbiased answer, that is, it is good or it is bad, irrespective of any influence. Okay.
Thanks, Ash.
Thank you.
I appreciate your response.
So here I am in AWS. I am in the core AWS. It's not the AI part only. This is entire AWS, from storage to compute to notification to functions to user management and so on. One of the service here is SageMaker. SageMaker is a platform where you can build model in all the possibilities, whether it is with code, without code, no code, low code, whatever possibility of ML it is possible with SageMaker. So you have SageMaker as one of the tools in AWS, where you can go and you can manage a lot of things from model training to data processing to data governance. Okay, multiple things about data governance. There's something called as ground truth that we will come to, which is about model data labeling. We need to understand what is data labeling, and then we will see what ground truth can do. Inferencing, which is making predictions from model in batch or as an individual prediction. We can get recommendations on what type of inference should we use. We have AWS Marketplace, which is amazing. So here I would also, plug the question of the participant I was talking to, Shrikant, maybe. So the question was, what are the solutions available if I don't want to train? So we have AWS Marketplace, which offers you a lot of things. Some of them for free, some of them on a chargeable basis. First thing it offers you is a lot of pre-trained models. Right? Pre-trained models. You don't need to do anything. You can start using it. They are driven by multiple companies. Few of them are driven by AWS itself, but few of them are by third party like Navinfo and Emphasis and Persistent Systems and so on. So if you want vehicle damage inspection as a model, it's pre-built. You can use it. Is it free or paid? You can check it in detail. Okay, you can see pricing and 0.00 looks free. Looks free, but you can read more about it. Okay, so there's infrastructure pricing that you have to pay. The inferencing price is 0, so there is no cost to that. I am not going in depth, but I'm giving you an awareness that there are pre-trained models which are also available. In the COVID time, there was a PPE kit that you used to wear, you were supposed to wear in certain requirements. So there was a PPE detector model, maybe not very useful now. Passport data page detection, a lot of different use cases which can be solved. If you don't want pre-trained model, you can get multiple algorithms which are offered by multiple third-party companies and AWS itself. Like there is one by Active AI called as Cognitive Q&A. There's a facial recognition algorithm for images. It is not pre-trained. You have to train it on your data, but you don't need to write the code for facial recognition. It's already written and you can start using it. There are a lot of other things available here. You have data exchange product called as WWII for generating synthetic data on lung cancer. It is not a very much developed product as of yet, marketplace, but there are some options. I am expecting to see more options here. Let me see if I have more feature algorithms. There are many featured algorithms that you can see. If you want IoT, there is something. If you want DevOps, you have something. If you want machine learning, you have something, so on. Apart from that, SageMaker also provide you a lot of pre-built algorithms. Linear regression, decision tree, all of them are also pre-built algorithms. You don't need to build that on AWS. You can upload your data and you can say, I want to implement this algorithm, and that will be enough. So there are 162 SageMaker algorithms pre-built. If I show you some of them, which you might understand, let me search decision tree. So there are 2 decision trees model which are provided by Rocket ML. If you want to implement gradient boosted decision tree, now what is gradient boosted? It will come later. If you want to implement this model, just click on it, upload your data, and that's all. Right? That is all what is needed. You can subscribe to it, check its pricing, which is there, it's paid model. And if you're okay for the pricing, you can start using it. There is a usage guideline for that. Yeah, apart from this, SageMaker is a platform which can provide you a lot of other solutions for machine learning and deep learning needs. You can upload your data and start training a model. In SageMaker, there is a platform called as SageMaker Canvas, which is a no-code machine learning solution. You can do a little bit of drag and drop. Let me show you if I can quickly. It can take a lot of time, so I'll choose to skip it right now. But if you just simply search for SageMaker Canvas on YouTube, you'll get enough of detail. I can also share you this link on chat, but there'll be many more videos on YouTube for this, wherein you can use no-code solution. Okay, I got some question, I guess. Is it possible to build product prototype using no-code data? Of course. You can use them. Why just prototype? You can also build full-fledged product on no-code solution. Can I use these models and put in my local embedded machine? No. Okay, using AWS Neo, you can. Yes. I was thinking you were saying kind of a download and then use it. That is not possible. But using AWS Neo and Greengrass, you can put it in edge devices, which is called as edge computing. And you can make an IoT solution out of it if you want to, or a edge solution out of it. But then again, you'll still be paying AWS for every transaction you make. Now I'll go to azure.com, portal.azure.com, sign in with my account. And I'll show you, can we customize models? Yes, what I have shown you is the pre-built model. If you want to make your own model from scratch, you have entire Jupyter notebook available, right? You have all the flexibility. You can create your own notebook instance, run some Jupyter notebooks, start from scratch, make the model as you would like to, with your own way. Any marketplace model is not available for any sort of customization. Whether you can either use it or you can not use it. You cannot customize it. That feasibility is available in generative AI, which we call as fine-tuning the model for different reasons. We will discuss that when we will come to generative AI. But machine learning model cannot be customized. To be fair, the architecture of machine learning model is not designed to be customized. Similar to that, in Azure, we have an Azure machine learning platform. If I create a workplace, it can take some time. Let me try that. So I'm creating a machine learning workplace. Whatever is Central India. It's a time-consuming process, so I'm kind of warning you up here that it can take some time. A few minutes, up to 5 minutes maybe. Okay, so this is similar to SageMaker. It will give you a studio where you can upload your data, where you can create your model, where you can tune your model, and so on. We also have tuning here, hyperparameter tuning, where you can customize, where you can tweak your model, the one that you have trained, and get the best out of it. You can compare multiple models against their performance. You also have augmented AI, where you are involving human and AI together in a single project. So we will learn all of this or most of this during our course. Meanwhile, Saurabh has raised hand. Saurabh, is there any question you want to ask? I have given you unmute access. Saurabh, please unmute and ask any question if you have. Okay, I hope there's no question. So this is deploying along with other things like storage, application insight, and so on. And you can't find. Okay, you can type down your question on chat always. That is an option.
Thank you.
Yes, Saurabh, you have any question you want to ask?
Is it audible?
I can hear you. Yes.
Yes. No, I was asking like on Amazon SageMaker, if we build on ML algorithm to deploy whatever it is, so can we test, like how can we test? Suppose we have we will create own machine language, model, ML model.
How can you what? Sorry, taste. I didn't understand.
How
this.
can we test?
Test. Okay.
Yeah.
So what you do is you can make your custom model in notebook section. If it's in
Okay.
Python, if it's in R, you can make it in R Studio section, and you
Okay.
can register your model. Your models will be visible. Let me show you where.
So is it chargeable or what?
Well, of course, running a Jupyter notebook or an R Studio is charged. It's not very expensive, but it is a charged process, right? However, it is having a free tier as well into it. Let me see, where is the model? There we go. So this is a place where all your models will be listed. Obviously, it's a dummy account, so I don't have any model. And once you get the model here, you can test that model with this feature, or there are many other features, right? You can pass on a lot of data to it, get the output, and then compare the actual output with the passed on outputs. And you can also do it in your notebook itself. If you are a Python user, if you are a machine learning user on Python, you must be aware of how to test a machine learning model. Make sense?
Okay.
Great.
So for free tier account, it is chargeable or it's
No,
not?
no. Free tier account, the name itself is suggesting there is some quota, some limits up to which you can use AWS for free. Post that, it will charge you. So if
Okay.
something is available in free tier, it will not be charged. If what is available in free tier, let me just show you. If you search for free tier AWS, there is a very good platform where they show you how much of what is available. Right? So you can search for SageMaker. There you go. So it is available with 2 months of free tier trial with certain restrictions like 250 hours per month and so on. So you can read about it.
Okay.
I'll send this link on chat to everybody. Okay. Okay. Obina, I have given you unmute access. Please unmute. You may
Okay.
have some questions.
All right. Thank you. Yeah. Can you
Yes.
guys? You can hear me, right?
I can. Yes.
Okay. Yeah. I've heard a few people ask you almost about the same question, and I think I have a similar question. And the question is, if you are not given the model conditions, how does it know that
Obina, your voice is
isn't there some
breaking.
kind of parameters? Or, yeah. Can you hear me?
I can. Maybe you're saying how does it decide which conditions to pick at what place? Is that what your question is?
Yeah. How does it know when is right? How does it know the right output? Like
Right.
what you're looking for?
That is where intelligence comes in. That's what we are referring as intelligence, which is the output. But then how does it go to that output? How does it create that intelligence? Based on a lot of mathematical detailing. Okay, if you have studied stats, there was a term in stats called as variance. There was another term in stats related to stats called as probability, which is more generic and more common. Based on a lot of mathematical detailing, what model is doing is not any sort of magic. These algorithms are designed in a way that they will extract patterns out of your data. That patterns can be identified by making trees, which is a decision tree type of algorithm, or those patterns
Yes.
can be identified by making linear lines, which is called as linear regression, or by making some hyperplane. What is hyperplane is something that we have not discussed yet, but that type of algorithm is called as support vector machine, and so on. So they use mathematical formulas to figure out this. Now, if I give you a little more insight on decision tree, what they do is they try to create homogeneous categories from your data. Let us say you have data about people who are passing the exam and failing the exam. Their data size is 1 lakh. Okay, I'll choose the other one. The data size is 50,000. 30,000 people pass, 20,000 people fail. So the first category the model is going to choose is something that can make your data more homogeneous. Instead of 60%, 40% as the ratio, can we come to 80%, 20% as the ratio in one category? More homogeneous, more dominant categories can evolve.
So okay. So what I understand that you just said is when it gets the data, it goes through the data, analyzes the data, comes up with patterns, right? And those patterns, it can keep refining, fine tuning,
Yes, in a
or
way, yes.
making sense of those patterns. So you yourself give it data. So regardless of whether you know what you want from the data immediately or not, the use cases could vary.
No, no,
But
no,
through
no,
the
no. No, we know the use case. According to the use case, we choose the algorithm. The algorithm just execute that use case. The
but
decision
how do
tree.
you give it the use case if you're not giving it the rules? Do you understand what I'm saying?
Yes. So see, let's say I give it the details of 500 cars along with the pricing. So what is my use case? Find the price of the car for any new car. If I'll tell you, what is the rule? I don't know. I really don't know what rules are applicable. I'm just giving data. Find the rules from the data itself. I hope it's making sense. You muted yourself. You can drop on chat if it is clear to you. Okay, anyways, we will go more in depth of how the models work, how the algorithms work. We will train a lot of models throughout this journey. So it's not a one-day class. This is just the first day. If you're getting a lot of questions, that's a great sign that you are involved, you are invested in the course, you are curious. Great to see that. I might take 5 more minutes. I know it's above the time limit. 5 more minutes, not even 5. I'll show you what Azure AI is. You can see a place where you have multiple solutions, like same as AWS notebooks. You have notebooks here. You have automated ML, where you don't need to write the code. You just put the data, and automatically Azure will figure out what machine learning model should be best suitable for your particular data and use case. You also have designer, where you know what is the best algorithm, you want to use it your way, but without writing code. You can upload your data and you can say, I want decision tree. You just drag and drop a decision tree component into it. Okay, that is what, if I show you a quick screenshot, because building it will take time. So this is how you can make a pipeline. And my first component is this, and my second component is this, and so on. Right? Instead of writing code for that, they are pre-built components. There are a lot of other things like data models, same as that, same as your data labeling, which was referred as ground truth and as in AWS. Now with that, I end my session up here. I stop my screen sharing.